Hi, everyone. So my name is Joe Stubbs, and I am the PI of a project called Tapis. And I'm joined with a bunch of my fellow co-PIs and personnel on the project. So Steve Black, Anagha Jamthe, Mike Packard, Sean Cleveland, and Jared McLean. And we're here to give you a tutorial on what we call building portable, scalable, and reproducible scientific workloads in the cloud and HPC, and it will primarily be using Tapis. Let's see, so some kind of administrative things to get started. So first of all of the materials that we're going to be covering today are hosted on GitHub. The screen I'm sharing here is the GitHub pages rendered version of the materials. So there's actually kind of two ways to view the materials. There's the raw GitHub repository itself, and then there's this GitHub pages. So that is the URL up here. We'll be blasting that URL, around all throughout the day today to make sure everybody knows where to find that. And let's see. And then also we'll be doing a lot of hands-on work today. So you should have received an email, I believe, right, Anagha, an email with a password in it for a virtual machine that we have provisioned just for this tutorial. So in a moment, when we get to the beginning part of the hands-on portion of the content, we'll explain in more detail where you're going to use that credential. And yeah, let's see. I think we can just go ahead and jump right in. I will say that we're going to start, it will mostly be hands-on. We are going to start with a little presentation on the course and Tapis. We think it's often helpful to kind of set the stage for what we're going to be talking about, but this won't take too long. And then we'll jump into a hands-on portion. And so I will go ahead and begin and with the presentation here, as well as with any of the other segments of the tutorial, please feel free to ask questions, interject, raise your hand in the Zoom or otherwise just speak up. That's totally fine. If you have a question or if something isn't working, we're happy to help, and we want this to be as interactive as possible. All right. Well, so without further ado, then let's go ahead and jump right in. So there again are the course material links. So you should see there the raw GitHub URL as well as the GitHub pages with the rendered material. So everything we're going to be doing again today will be available there from GitHub. Just leave that up in case anyone's getting it. A second longer. Okay. All right, so what are we going to talk about today? So the ultimate goal here for the tutorial is for you to have a basic understanding of associated challenges with computational research, some of the tools that we have available in the community for computational research and these challenges. And we're going to talk about the Tapis project in particular. So this is the project that we'll be using for the most part throughout the tutorial, and we've built it expressly to address some of these challenges that arise in computational research. But it's not just Tapis that we'll be dealing with today. We'll also be talking about container technologies, Docker, as well as Singularity, and Jupyter notebooks. So everything we'll be doing today, we'll be doing inside of a Jupyter notebook, and Jupyter notebooks are great tools for research computing and scientific computing. And at the end, the ultimate goal is to show you how to use the Tapis APIs to automate a workflow, a computational workflow. And we'll actually, it says HPC there, but actually we'll see how the same workflow and more or less the same automation can be pointed at either a traditional HPC machine or a cloud resource. So yeah, again, just to kind of set the stage, we thought we would give a little bit of an introduction to Tapis. So to set the stage for that, we see that the national cyber infrastructure ecosystem really provides a great deal of powerful tools and capabilities for research computing, right? It's a powerful and it's a robust ecosystem, but it's also a heterogeneous landscape. There's a lot of different specialized systems spanning a number of different areas. These are areas like high performance computing, but also high throughput computing, data science and visualization, large scale data management, cloud computing, experimental architectures, right? So there's just a large breadth of different kinds of systems specializing in different technologies. And all of these areas really involve their own sophisticated ideas, their own sophisticated concepts. And so a researcher who is an expert in a particular field like biology may not have the skills or the resources available to them to take advantage of all of these systems and resources. So just at TAC, the Texas Advanced Computing Center here at UT Austin, where a lot of us are, we have over 12 production systems. And these are the ones on the slide here. And you see that most of the architectures, computing models, paradigms of the previous slide are covered. So we see this as just a lot for the computational researcher to master on top of their own research domain. Then if you go to talking about distributed computational research, where your research involves spanning multiple physical resources, then a number of additional challenges are introduced, right? So typically this distributed research is a multi-stage endeavor. So for instance, you often begin by interacting with instruments to get at raw data. And these could be sequencers or telescopes or shake tables, lasers, other kinds of instruments. So you've got to get at the raw data, and that's a challenge in and of itself, potentially. Then there's often a pre-processing step that happens, and there's a lot that can happen in the pre-processing. This can be anything from kind of simple quality assurance to a bit more complex, like extract, transform, load kind of script, all the way up to sophisticated machine learning processing that's happening on the data. Once you've kind of pre-processed the data, you typically pass that to, what would be traditionally called an HPC workload, a model simulation. And that does involve a whole host of additional technologies like MPI and OpenMP, but also where, there's the field is also innovating all the time, and GPUs and other kinds of techniques are coming all the time. And then finally, assuming you get some results that are valuable, there is the challenge of disseminating those results, sharing them potentially initially privately with a set of collaborators, and then more generally to the public, to the community, once they're kind of finalized. And and there's issues, challenges associated with the dissemination itself, right? Like reproducibility and the data provenance and things that need to come up. So really, the Tapis project is an NSF project with the goal of helping you tackle some of those challenges. So broadly speaking, Tapis is a web-based computing framework. It supports computational research really in any domain. So we're sort of domain agnostic. It's not just for biology or astronomy or anything. It's a domain agnostic framework that is, to be a little bit more technically precise, is a set of hosted, that is running for you, running at TAC, at the University of Hawaii, at other data centers, running for you in the cloud as a set of RESTful APIs. And we'll mention a little bit about what REST is, but HTTP APIs together really with an ecosystem of tooling. And this includes software development kits in different languages like JavaScript, Python, and Java. We have an official command line interface, but with the primary goal of managing data and executing code on these disparate resources. So we'll say that kind of over and over again, that managing data and executing code, that's really at the heart of what we're trying to help you do on these various kinds of resources: high performance, high throughput, and cloud computing resources. So we kind of have three higher level objectives to go kind of one layer deeper with Tapis. The first one is programmable access to these resources, right? Programmable access to the HPC and cloud resources. We want you to be able to conduct these analyses on on these machines in an automated way, right? As opposed to the traditional ways, which tend to involve manual activities, like manually SSHing to a login node, manually submitting a batch job, manually monitoring that job to see if it worked. We want you to be able to write a program that does all of the steps, and therefore, enable you to share that program with others. So reproducing your analysis is a key goal for Tapis as well. So every activity that you take in the platform, for the most part, every major activity is recorded in the form of history inside Tapis. So Tapis records, for instance, all of the inputs, all of the outputs, all of the parameters that were used when executing a workload. It records the different versions of the applications that were used, et cetera, so that you can replay that analysis at a later time with the hope of reproducing your results. And finally, for the collaboration, enabling collaboration is the third key goal of Tapis. And we do this by basically putting access controls on all of the digital objects that you create within Tapis. And those digital objects within Tapis that you create, they start out as private. So only you're able to get at them. But through the various APIs that Tapis provides you, you can share those objects with other people. You can share them with individuals, or you can share them to entire communities. And again, all of that is a software stack that is running in the cloud. So you just use it the same way you would use a website. You don't have to install anything or administer anything. So we'll go into a bit more of the capabilities. There are 2 production versions of Tapis. In case you're somebody who's been using the project for a while, you might be familiar with version 2 of the platform. There's also version 3, which was released in September of last year. And these are the primary capabilities. So systems, files, apps, and jobs that were there in V2. There's been a refresh as part of V3, but these are really sort of the core data management and code execution APIs. We'll say more about those. But we have a number of other APIs. So we have a metadata API, which allows you to manage very large, as on the order of billions of document objects. We have a functions as a service. We have an authentication module that allows you to do OAuth 2 and OpenID Connect with Tapis. And then V3, you can see here, has added a number of new features on top of V2. So first class support for containers, and everything we'll be doing today is within a container. So we'll be talking a lot about that. In V2, you can use containers for your applications, but there's a lot of kind of manual work that you have to do in terms of setting those things up. In V3, containers are a first class citizen, and the API understands and has a lot of semantics for different container runtimes. The Streams API, which we won't be talking about much, but does support processing sensor data in real time. A decentralized security kernel, which allows other institutions to run Tapis, but in a way that federates and coordinates with other institutions that are running Tapis. And then we have a new service called PG REST, which is kind of like our document store, except it's Postgres on the back end, and that gives you the ability to do work with relational models. So I want to spend just a little bit of time talking about these 4 core APIs. Managing data, executing code. Again, those are the key themes, the bread and butter of Tapis. And they're accomplished through these 4 APIs. And we'll be talking about these APIs throughout the day, but just to kind of start you off with a primer. Systems, files, apps, and jobs. So the foundational of all of these APIs is the systems API. You register systems with Tapis to represent the resources you want Tapis to interact with on your behalf. And this is a really key point. So, whether it's the Stampede 2 or Frontera supercomputer, or a high throughput server running in your lab, or an Amazon AWS instance or an S3 bucket, Tapis doesn't have a binary or any kind of installation running on that server. Instead, what you do is you register a definition of that resource with Tapis, and you tell Tapis how you want it to communicate with that resource. Okay, and in that way, we're able to communicate with a lot of different types of systems without any kind of installation happening. So systems are sort of the foundation. You register the resources with Tapis that you want Tapis to communicate with. And once you've done that, and that's a sort of one time or just a few times kind of thing that you do, you can then use the Files API to actually manage data on those resources. So you can ingest data, upload data, move data between systems, and download data, get data out. And that's all through the Files API. All right, then on the other side of the coin, the executing code, we have apps and jobs. And so apps is kind of mirrors or is similar to systems in that this is where you register the executables that you're going to want Tapis to invoke on the systems, again, on the resources on your behalf. And so again, similar to systems, you register apps, one or two times, a few number of times. Apps tend to evolve a little bit more than systems do, so there are different versions, and we'll go into all that. But you register the application, one time, and then you use the job service to actually invoke the application, to execute the application on a system. And so you may call, the job service many times for one application, because you may want to invoke it a bunch of different times. And the job service is the thing that's capturing all kinds of metadata about what happened. The inputs that were used when running that job, parameters, options to the application, et cetera. And so all that is available through the Jobs API. All right, that was a crash course. Again, we'll be revisiting these four APIs quite often throughout the day. Okay, so how do I use Tapis? Well, so if you're not familiar with what a REST API is or what an HTTP API is, it's really, like I say, it's a lot just like a website. So you can use any kind of client that can communicate, that can talk HTTP. And so if you're familiar with the command line client on Unix style systems, you can use curl. And there's like a little example of how you might list applications, list the applications you've registered with Tapis. We have an official command line interface, as I mentioned. This is similar to curl, except we think the syntax is a bit friendlier. If you have used curl, you might know that, or you might feel like the syntax can be tricky to get right sometimes. The Tapis CLI tries to make that a little simpler. For folks, though, who want to work in a programming language, we have official software development kits like TappyPy for Python. We have a TypeScript library and also a Java library where you can use sort of more idiomatic and sort of language native syntax. So here is an example of how you would submit a job in the Python SDK TP, the Tapis object.jobs.submit. And we'll, of course, be using that throughout the day. And finally, it's possible that you're using Tapis without even knowing it, because there are a number of web applications, science gateways, as we all know from this conference, that are built using Tapis underneath. We also have Tapis UI, which I think we'll mention a little bit today. So this is an official project, part of the NSF grant, and it's developed both by folks at TAC as well as the University of Hawaii to provide a full front-end application. One of the cool things about Tapis UI is that it is a purely static application. In other words, you don't need any back-end servers to run Tapis UI. You can run it right out of GitHub. And that's what we'll see today, and that's what we'll do today. So you can actually fork the repository on GitHub, reconfigure a file in there that has some basic configuration for Tapis UI, and then serve it up out of GitHub pages, and all of a sudden you have your very own web interface on top of Tapis. Yeah, so that's Tapis UI. We will discuss that later in the workshop. So who's using Tapis? The list grows. Actually, every year we add collaborations and projects. It really is being used by quite a few different science gateways, but also NSF-funded institutes. We are the foundational software framework for Icicle, which is a brand new NSF AI Institute, 5-year, $20 million AI Institute. We just completed our first year. We're used by NASA, NIH projects, DARPA projects, And we have a number of centers and other institutions that are integrating with Tapis. The University of Hawaii and TAC, of course, but also Compute Canada, Ohio Supercomputer Center, and San Diego Supercomputer Center, as well as UT San Antonio, are all have all deployed Tapis components or are in the process of deploying Tapis components. So this is just a screenshot of some of the different science gateways that have been built with Tapis. You may recognize some of these bigger projects like Cyverse or Design Safe. And you can see they really are used across a variety of domains of science and engineering. And so with that, I'll conclude. I just conclude this slide here with links to some more information. So for your reference, so we have extensive documentation. We have a sort of narrative style documentation on the Read the Docs. We also have what we call OpenAPI v3 live docs, which are sort of precise definitions of all the API endpoints. And we also have an active Slack team. So you're welcome to join our Slack team. And we have a full support where we monitor the Slack regularly. All right, so thank you very much. Those are the course materials again, in case you missed it before. And with that, I will conclude the presentation. See if we have any questions out there. Not really looking at Slack or Slack or the chat.
I don't see any questions in the chat, so.
Cool. Thanks, Sean. All right, well, maybe we should jump right in then. So here are, again, here's the GitHub pages for the course materials and the schedule here. So so we're going to start off with this section, running Jupyter Notebooks on Google Colab. So let's see here. You can see here the left navigation. So introduction to Jupyter, I'm going to go to there. So this is where, if you're going to follow along today, this is where we're going to get started, and I'm going to do this part as well. So what we're going to do is we're going to use Google Colab to launch a Jupyter Notebook and walk through a series of steps to interact with Tapis, and we're going to execute some code and stuff. So the first step is for you to actually log in to Google Colab with your Google account. So this does require you to have a Google account. If you click this link, it should open you up into a new window, and you'll see these tabs here at the top. So what we've done is we've provided a notebook on GitHub. So you can click this GitHub Notebook tab here, and then come back over to the docs and paste this URL. So just copy that all the way to the Git. And after clicking the GitHub, just paste that there and search. And it should pull up this one file, imageclassify.ipython notebook. So you should be able to click that. And it should open for you this notebook file. So you're running here inside Google Colab, you're running our notebook. So historically we've done similar training sessions before. Sometimes this can be a bit of a confusing point. So I'm just going to pause here, give everybody a couple minutes to make sure that they can find this notebook and open it in Google Colab. How are folks doing? Have they been able to open this notebook file? maybe gesture on the Zoom or give us a thumbs up or something. Cool. Seeing some thumbs up. That's great. It's like some people are still working on it, so I'll give it a few more minutes or a few more seconds maybe. But again, yeah, from this, copy the URL here, click the Google Colab link. Make sure to use the GitHub tab here and paste that link, and you should see this image classify file. And then the Zoom control bar will get out of the way. Sorry, Zoom control bar was in the way. It should open up this. All right, anybody having any problems? Okay, so if not, I'm gonna move forward. So this is a hands-on. So if you're not familiar with Jupyter Notebooks, this is what the environment looks like. We're going to be writing Python code, or actually really mostly executing Python code. Most of the code we've written for you here. There are some places where you're going to have to edit the code, but the code, if you're not familiar with Jupyter Notebooks, lives in these code cells, what are called code cells, and you can type the code and then you can execute the code either by hitting Shift-Enter or by hitting this play button right here. Now I said it's Python code, and that's almost true. You can actually mix Python code and little shell commands. So actually, the very first thing we're going to do is we're going to install the Python SDK for Tapis, the TapPy library, and this is a pip install. So this is actually a shell command that you would run on your own computer or on your own laptop, for instance, if you wanted to use this there. But so we're gonna do that. When you click the play button, it's going to execute the code, and then Google is going to warn you, hey, we didn't author this notebook, so just warning, you're actually running something to install something that we didn't author, and just click run anyway. That's okay. All right, now you'll see the thing spinning. It just went away, and then you'll see a green check. So it spins while the code in the cell is executing, and then it gives you a green check when the execution of that code is complete. And if you're running the pip install, you should see output, and that's generally going to be the case with all of these Jupyter Notebook cells. You're going to see output beneath the code cell that that describes whatever execution just completed. And yeah, and so here is the output for that installation. It should have worked for you, but here is a key point. And I'll say this because usually we have people who don't do this, and then they're a little bit sorry. But after you do this, you need to restart the runtime. So go to the menu up here, go to Runtime, and click Restart Runtime right here. You need to do that so that the Jupyter Notebook recognizes the new TapPy library that you just installed. And it'll say, are you sure you want to do that? Because any local variables that you've set up have been lost. That's okay. We haven't set up any local variables yet. And that's why I say you want to be sure you do this before we start executing the other cells, because then we will have set up some local variables. And then we'll be sad if we have to do this, because we have to rerun those cells. But right now is a perfect time to restart the kernel and the notebook kernel, and then we should have TapPy ready to go. So again, this can be a little bit of a time, can take a little bit of time to run through this, but it should work. Is anybody having any issues with the installation? Checking through the channel here. I don't see anybody with hand raised. All right, so I'll proceed. Again, feel free to just raise your hand or put a comment in chat, or even just speak up. It's totally fine if you're having problems. But so now I'm going to go to the second potential place for there to be some confusion. In the past, there's been some confusion, and that is entering your training account information. So So I'm going to try to describe what we're doing here, because again, there's been some, historically, these two cells are the cells that people have problems with. After this, everything works very smoothly. But if there are any bumps, it's here. So what we're going to do here is we're going to configure our Tapis object with or rather, we're going to configure some local Python variables with the information we're going to need to create a Tapis object. And that Tapis object is going to be the thing in Python that we use to actually make API requests to Tapis. So when you play this cell, when you click play, you can see it's spinning. It's going to prompt you for a bunch of information, actually exactly 4 pieces of information. And it's really important that you get the information inputted correctly here. So there are 4 pieces of information. The first 2 are the username and password associated with the Tapis account that you're going to use. Now today, that is a training account. It's going to be something that starts with TRAINING, training, and then some numbers. And this should have been, Anagha, correct me if I'm wrong, but this should have been shared with everybody through an email. Is that true? The training account?
Actually, it's on the Google Doc that we've shared with them.
On the Google Doc. Okay, cool.
Yeah, sure.
Yes, on the Google Doc. You should, okay, so you should find you should find your name on this Google Doc, and there should be, training some number and your name. So I'm going to use training 52 for myself. Enter. And then you're going to be asked for the password. Okay, you're going to be asked for 2 passwords. So this first password is going to be the password associated with the training 52 account at the Tapis level. And in this case, it's the same as the username. So in my case, I'm going to hit training 52 again. So it should be the same as my username. All right. Now, hit enter. Now I'm going to then be prompted here for a password for a virtual machine. So there is a completely separate credential that is again on this spreadsheet that is the password assigned to your training account for the virtual machine. So I'm going to go over here to the Google Doc. Oh, if I can I move this out of the way? Yeah, let's see if I can move that. So I'm going to go over here to training 52, and I'm going to grab from, this is the thing they can see, right, Anagha?
Yeah, they can see this, and the VMs are also in the same Google Sheet. So
great.
On the very top, yeah.
Yeah, so I found training 52 because I did this earlier, but that's my second account that I'm going to use today. You'll find your name and the VM password, which again is in column B. And that's going to go right here for password for VM. So I'm just going to paste that in. And then lastly, the host. So this is the IP address of the VM. And so again, as Anagha mentioned, we have two VMs. So I'm training 52. So I'm going to use this IP address, 129.114.35.143. So you'll use the IP address associated with your training account. It will either be the one I'm using or this one. And so again, we'll paste that IP address in there and hit enter. And now the cell should be completed with that green check. And at this point, I haven't actually done anything with Tapis. I've just set up these local variables, username, password for the VM, and the host for the VM, the IP address. And so now what we're going to do is we're going to authenticate with Tapis. And I'm going to say a little bit about what's going on here. So we're going to create an object, a Python object. We're going to call it client, which is a Tapis object, a Tapis client object. And here we're passing just the username and the password. So that's that training 52 password equals training 52. We're gonna do this, and then we're going to call get tokens. So the way that Tapis works, it can be configured to work in multiple ways, but the way it typically works is through this token-based authentication, where in some way, some manner or other, you exchange your username and password for a token. And you do that one time every so often, every 4 hours or every day. And then you use that token to make subsequent calls to the other Tapis API. So you only ever pass your password to Tapis one time to get an access token, and then you use the access token from there on out. So I'm going to run this cell. It spins for a sec, and then it prints some stuff. Okay, and so I want to spend a little bit of time just kind of talking about what happened. So we had the training, 52 and password training 52. And that gave us basically an access token. So that was the correct username and password for the training project that we have for Tapis. And what you're going to see here are a couple of fields. So the first one is what's called a JSON web token. So the actual access token is this long string right here. All of them will begin with EYJ0, but then they'll be different towards the end. This is called a JSON web token. It's a standard, and it's one that many websites follow. Tapis is not alone there. And this token basically encodes some information. So it's not a token that has no meaning. It's actually, you can actually derive meaning from this token. And the meaning associated with the token is organized into what are called claims. And so here, the Python library isn't just printing the token itself, the raw string, it's also decoding the token and showing you the claims associated with that token. And so, for instance, we can see different claims in here, like the username claim. So the claims are organized as name value pairs, name : value. So the username claim and the value is training 52. So that's indeed my username. You can see other claims in here, like the account type is a user account. It's not a service account. You can also see that the token has an expiry. So all of these tokens are rather short-lived. In this case, they're 4 hours. You can see that the time to live there in seconds, 14,400 seconds, 4 hours. So the point is that now by passing the first username password combination, we have a token that represents our training account. Okay, and whenever we're going to make calls to the subsequent APIs, we're going to pass this token. We're not going to pass our password. We're going to pass this token. The API, when it receives it, the Tapis API is going to do this very thing that the Tapis Python library did for us, and it's going to get the claims out of that token, and that's exactly how it's going to know who we are, that we're training 52. Okay, so let's see. How is it going out there? Have folks been able to authenticate and generate a token? Maybe give a thumbs up if you have. Cool. I see a couple of thumbs up already. Very good. 5 thumbs up. Awesome. Awesome. Seeing a few thumbs up. So we'll say more about this, but it's important to keep in mind. And I have a little bit on this somewhere. Maybe I can show a little diagram. It's important to keep in mind that that there's sort of 2 levels of authentication that are going to happen with Tapis. So the first is the one we just did, where we generate a token. We pass our username and our password to the authentication module, and it returns this access token, this JSON web token. Okay, and then once we've done that, that's a one-time thing or a once every 4-hour thing. We're going to pass that access token on subsequent requests. So what are other requests that we're going to do? Well, we're actually wanting to interact with some of these. We're wanting Tapis to help us interact with some of these resources, maybe HPC, cloud, high throughput resources. So that's where we're going to use services like the Files API. When we make that request to say list some files, we're going to pass our JSON web token. And that's going to tell the file service that we're user Stubbs or training 53. However, the file service, when it communicates with whatever resource we're asking it to communicate with, it's going to use potentially a completely different set of credentials. It's going to use a different set of credentials based on the machine, the system that we're asking it to interact with. And that's where that VM password is going to come in. All right. So while we're JStubbs with this JSON Web Token, on this system, we might still be JStubbs, but we might be using SSH to communicate, and we might have an RSA key that is the way we communicate with it. Similarly, if we go to a different system, system 2, that might send Tapis over here to this cloud machine, this maybe an AWS instance, where the user isn't JStubbs at all. Maybe it's a Rocky Linux installation, and I'm using the user Rocky, and I'm using an SSH password here. So that's the most similar to the VM setup that we're going to do today. Again, the JWT on the front end, that's still the same. But on the back end, Tapis is using a different account. And finally, we can use a third system, which system 3, which may be an S3 bucket, say. And again, we are going to have the same JWT coming in here, but a completely different kind of credential, a third type that Tapis will use on behalf of that system. So there's a multi-level authentication and account mapping that Tapis enables you to do. One level is authenticating with the APIs, and at the other level, it's authenticating with the various kinds of resources on the back end. And we're going to say a lot more about this, but I just wanted to explain that because it's sometimes a point of confusion. Okay.
Joe, there's a question about Tapis and two-factor for HPC.
Okay. Yes. Does Tapis work if HPC systems use two-factor? Great question. So in short, not super easily. We do work with all of the TAC HPC machines here at TAC, which all do have MFA enabled. But we've worked out an arrangement with the TAC HPC admins to basically make it so that we can bypass the multi-factor auth at the login node level, and there's a special system in place to allow us to do that. So so that's the short answer. We also have an active project going on right now that would allow us to have a very general solution, which would basically allow users to use Tapis with an MFA system and have the MFA, the multi-factor auth, coordinated through Tapis's access of the system. That's in the works, but it's not ready there yet. So for the time being, we really do need multi-factor authentication essentially turned off for the Tapis agents that are going to communicate with the system. And we have different ways that can work, but yeah, sure. Good question. Anything else?
I have a question about the user mapping. I presume that Tapis is keeping track of who the real user may be if you're using this in a gateway situation for, say, accounting or quota kind of tracking?
Yeah, thank you. That's a great question. So yeah, if I can remember which tab my thing is in. Oh yeah. So yes, in short, yes, Tapis is keeping track of all of that stuff. And we've tried to make it very flexible. Like, in other words, we've tried to make it so that lots of different ways of interacting with the resources, or in other words, of doing this mapping, are available. So for gateways, for science gateways that want to kind of use this, I'll call it traditional service account model for those who may know what I mean. Like, in other words, they want all of their gateway users over here to basically interact with the resources on the back end as the same user, right? So that would typically be some HPC system maybe, and they want to use the same account here for all the different gateway users. That's possible. That's actually the easiest way to set up Tapis, to be honest with you, because in that case, Tapis just needs one credential, and then and Steve's going to say a whole bunch more about that. But then whatever user, Stubbs or Anagha, Jamthe, or Steve Black, whoever comes in, they'll be using that same credential to interact with the system. So that's the sort of service account model. It's nice because you don't have to have different, you can have kind of one big allocation over here and everybody uses it. The downside, that we see a lot, is HPC centers don't really like this, because you could have one kind of bad apple, so to speak, in the gateway user, and a bunch of, and everybody else is a good citizen, but it's unclear from the HPC provider standpoint who's doing the nefarious activity, right? Who might be stressing the file system or whatever. So from that standpoint, we also have, like I say, this mapping where basically you can have different gateway users going in with different accounts. But in any case, for any particular job or any file transfer or any activity really that Tapis is orchestrating, Tapis absolutely knows and through an audit or API request could tell what user, what identity it acted on that behalf. Does that answer your question?
Yes, it does. Thank you.
Okay, great. Thank you. That's a good question. All right. Well, if there are no other questions, I'm going to stop sharing because I think I'm done with my part. Yeah, and thanks everybody for listening.
Hello, everyone. I think I'm next. Is that right?
Right. Yeah.
Thanks, Anagha. So my name's Steve Black. Joe gave a great introduction. Thanks, Joe. So I'll be covering some of the core services and resource types that we've talked about, namely systems and applications. Let me go ahead and share my screen and share part of it. Let's see. So I'll be going back and forth a little bit between some slides, the material, and then the Jupyter notebook. So we'll do the hands-on stuff. And as Joe said, anytime, just raise your hand or post a question or unmute and speak up if you have any questions or have any trouble with getting things to run. So we'll do a little bit here. Actually running a little bit early, which is good. So I'll try not to go over too much, and then in about half an hour, maybe a little earlier, we'll have a break. So to schedule, and so I'm going to be covering Tapis systems and then applications. And just wanted to start with this the GitHub pages here, which gives a fair bit of detail, which I won't be going over in quite this much detail. But there's a fair bit here, and then also the read the docs probably has the most information, and then a fairly concise description of the API itself is in that live docs, which is based on the open API specs. So if you're using a client, especially say directly going to the REST API, you can look at that to see what options are available, what parameters you could pass in, and what's required, and so forth. So let's go ahead and get started with the slides here. See, I'm not sure. Unfortunately, a slideshow doesn't work well on this computer for some reason. Do this full screen thing and up a little bit. So as Joe mentioned, one of the core abstractions is the system. So we have something called a Tapis system, which is really an abstraction of a host or a cluster that you want to use within Tapis. And so essentially anything where you can give it an IP address or a fully qualified host name, you can create a Tapis system to point at that and have it look the way you want it to and behave possibly differently for each system that you define. So you could actually define multiple systems pointing to the same host. For example, you might have a host machine that you wanted to look like either a storage system where people don't run jobs, but also have a definition where it can be used for executing jobs and as storage. So if anyone's very familiar with V2, one thing that's a little bit different here is in V2, you had similar concept with systems, but they distinguished at a high level between a storage system and an execution system. And here that we don't have different types for that. We do have an attribute that indicates whether you're going to allow people to run, execute applications on that system, but it's not really a separate type. We'll go over that shortly. So, and what are they used for? As Joe talked about, for storing and retrieving files, for managing your data and files on various types of system. And you can list files, download files, upload files, and then also request. That's all synchronous. And you can also request transfer of files or files and directories from one Tapis system to another. And that happens asynchronously. And that's in fact what the job service does when it executes an application. So one of the main uses of systems is to run a job, to run your application on a host or a machine. And when that happens, the jobs will stage files to the system to get ready for running the job, and then execute the job on that system. And finally, when it's done, it allows for archiving the files and data somewhere else on the same system or possibly a separate system that may be set up, just specifically for storage. So when you do register a system, which we'll do shortly here, this is an example of what the definition looks like. So I'll just talk a little bit about some of the more important attributes. The most important one is the name you give it, the ID, the Tapis ID, which is separate from the host name. And one thing important about that ID is it needs to be unique within the tenant. So, Tapis does have a tenancy model, and normally that will be by project. For example, DesignSafe has a tenant, and then all the users and all the resources in that tenant are isolated from other tenants. So that ID needs to be unique within a tenant. And also the important thing about that is the ID, once you create a system, you're not able to remove it completely. You can soft delete it, which has a certain meaning, and undelete it. But you're not able to actually remove it completely without a support ticket. So, if you accidentally create a system with a name that doesn't work out, like you might accidentally create one that someone else needs to create for general use, you can have it removed. But the reason we don't allow removing the system by an end user is the provenance aspect of it. We want to make sure that system is there to be referenced. Like, for example, you might have run many jobs on that system. So we want to keep that record around. So just be aware that, once you create a system, you're not able to rename it. And then, so you do specify the system type. We support, so I think it's not listed here, but we support several types, including Linux, iRods, S3 buckets, and then Globus isn't there yet, but that's under development. Hopefully it'll be out before too long for Globus as a storage type system. Then you can have a description, just optional user provided description. And then each system has an owner, which you normally won't need to worry about. For example, today the definition pretty sure does not have owner, and it doesn't need to have owner, because by default, when you create a system, the Tapis user making a request becomes the owner of the system and has full access to the system. So we talked about the host, which is an IP address or a host name. Today we'll be using the IP address for one of the VMs. And then another very important attribute is the root directory, this root-dir, which allows you to create a system, and then from then on, any path you give Tapis will be relative, for the system will be relative to this root-dir. And Tapis go to some trouble to make sure that you can't easily, escape that root there in terms of specifying paths. Of course, when you run the application, your application, doesn't have, can try to access whatever it needs to from inside your application. But you will be running as a certain identity. So you always, of course, have the POSIX permissions on a Linux system, for example. So that's another critical thing that for a Linux system you are required to provide is this root directory. And here, this particular system example is intended to just be a storage system. So it has that can exec flag set to false. So the ones we'll create today will be setting that to true because we do plan to run jobs on there. And then something Joe talked about some is, so we've told Tapis now at this point, where the host is, where to go, where the system will point to and go. And then when you give it a path for a file, what's the root directory that everything will start with. But now we also need to tell it who we're going to access that host as. And that's what the effective user ID. And there are there are two types of options for this. One is just a simple static string, as is shown in this case. It's a string test user 2. And what that indicates is that when Tapis goes to contact the system, no matter who's making the request, no matter what Tapis identity is provided, it will always attempt to, in this case, it's Linux, it will always attempt to SSH to that host as test user 2. And the other option, which we won't talk a whole lot about today, we can make a system definition a lot more flexible, is you can make that a variable. I think a $ API user ID, which basically indicates to Tapis that it should try to SSH to that host using different users depending on which Tapis ID is making the request. And by default, it actually will be the Tapis username. So for example, today we created a token for, say, training 52 that Joe used. So if this system definition had that $ API user ID and then training 50 or training 60, I think is the one I'm using, try to use the system, then Tapis would attempt to SSH that system as training 60. But of course, the actual host names, usernames on the host might be different. So there is a provision for mapping the Tapis identities to the host login users. And we won't go into that in a lot of detail, but there is that provision when you register a credential, you can basically tell Tapis, when someone comes in, is this Tapis identity, like training 60, I really wanted to log into that host as SC Black, which is maybe not a Tapis identity at all. So now Tapis knows where to go and who to go as, but the other thing you just said is how to authenticate, what authentication method. And that's the next setting there, which in this case, it's telling Tapis it will be SSH keys that will be used. And the one we'll see in the hands-on is the passwords, of course. So that tells Tapis you're going to use, in this case, SSH with keys to access that system. But one thing you notice here is that so far Tapis doesn't know the actual password or key pair to use. So you set that in a separate step. So as Joe did a good job reviewing the various ways to access Tapis through curl, directly to the HTTP calls, or the Tapis UI front end, which we'll see a little bit of, and then the SDKs like the Python, Java, or the CLI. So, okay, let's jump on over and actually try some stuff out over here. So I'd set this up earlier with hopefully I'm training 60. So we're going to be going to the notebook. We're actually going to create two systems. So, I mentioned before, you can have multiple systems pointing to the same host. So that's what we're going to do today. We're actually going to create two systems. One's going to point to the VM and set it up as a sort of a traditional just Linux host, where you might just SSH to and run jobs manually. not through a batch scheduler. You might run programs directly, which tend to call fork type applications. So we'll set one up that way, and then we'll also set up another one. So this particular VM actually has quite a bit installed on it. So it can act as sort of a traditional VM, or it can act as more of an HPC type resource with a batch scheduler. It has Storm installed on it and Singularity. So we'll see that today too. So this one, this system definition, so we should be able to just run this and create the system. Most of this we've talked about already, I think. You see it puts the router at whatever training ID you gave, and it also has the CAN exec to true. One thing to be aware of is you see that CAN exec is has a capital T because it's the Python SDK, but if you're using a JSON and going through Perl or something different, I believe it's a lowercase. So something to be aware of. And we're also telling Tapis here what runtimes this system supports the job when you're running jobs. And in this case, we're going to be using well, actually, yes. So that's one thing I think Joe had mentioned is, we have this first class support for containers. So one thing we do need to let Tapis know is essentially whether you can be using Singularity or Docker to run your container. So here, in this case, we're going to be using Singularity to run the container. And finally, we have this job working dir, which is tells Tapis that when an application is run on here, where do you want all the activity to happen? Where do you want the files to be staged to, and where do you want the job-related directories to be created? So we'll see examples of that. But here we're just using this working dir called work dir, which will actually get put under the root dir. So the actual full path to where all the jobs will be run will be /home/training 60, in my case, for example, /work dir. So I think, I believe the job service will actually create a directory under there called jobs, and then by default, it will create a jobs directories under there by job ID to sort of contain everything that associated with that job. So let's go ahead and run this to create our first system. We get the green check mark, which is good, and we get back a URL, which indicates that Tapis did create that. And you can see mine is called Gateways VM Training 60. So that looks good. And then, so once you've done that, if say there's a problem with that, or if you decide you want a different description, for example, you have a couple of ways to update things. One, which is commented out here, is the put system, which allows you to essentially either use your original definition, JSON file, or maybe get the definition and modify it, and then just do put. And it's similar to the create. It will allow you to just send the whole definition. It will ignore things you can't change. For example, the ID can be in there and will be ignored. And then just apply the updates. But you also have the ability to do a patch, which is what this next cell is going to do. Here I'm going to just update the description using patch. So you can just put whatever field you want to update. And assuming it's updatable, which they not all are updatable, it will apply that change. So here we're just changing the description. And again, looks like we had no trouble. And here, so now we should be able to list systems. And you can see here, I actually run this earlier before I created the system. And I got back an empty list. Right? There were no, training 60 had not created any systems yet in the training tenant. So we can run that again, and hopefully we'll see our one system. And so here, when you list systems, you get what's what are called summary attributes, just show some of the more important attributes of that system. So you don't just see too much information at once. And there's a way, actually, there's some parameters you can give it to say you want to see certain things. You can see all attributes, or you can just select certain attributes. So it does have that capability when you're listing systems. And we can get the, so now we've created that, we can fetch that system and see all the details for it. And you see earlier I ran this and it wasn't there yet. So this time we'll run it and we see all the details. We get back all the attributes for the system. And you should see everything filled in. See, so yeah, so the effective user ID is training 60. The owner should show up here as training 60, and then the tenant is the training tenant. So we have all those attributes there. And then Tapis does assign a UID to the system, but typically you won't need to worry about that. But those become more important for jobs, but for system, that's only something you need to worry about. So now we need to let Tapis know. So Tapis now knows, what host to go to, how to go to it using it. Let's see, we should have set password, right, as the authentication type. So yeah, we confirm that authentication is set to password, but Tapis doesn't yet know the password. So we need to let Tapis know that VM password, which we set up earlier. So we can run that. And the credential got updated. So this is an important step, especially when you're using SSH keys, because they can actually be tricky to get in the right format to update. So by default, when you register credentials, Tapis will attempt to contact the system, the host, with those credentials. And if it's not able to do that, you'll get an error here. You'll get a message back indicating that, basically your credentials did not work. Now, in case you want to register credentials without having the system fully set up yet, you can do that. There's a way to bypass that credential verification. But by default, it will check it at this step. So now we can actually use that system to do something. We can call the file service. You can see this call is client.files. And we're going to list files at the root directory. At the relative directory, which is the relative to the root dir defined for that system. So we should see files that exist there under /home/training60. So the file service is basically contacting systems to get all the system information, and calling the host to list the files. So we see here we get a list of the various files and a lot of details about the files, including the hidden files like .bashrc. So that was for the VM. Now what we're going to do is actually, since that we know that VM, and to show you how you can create different systems, run different types of jobs, we'll go ahead and create a second system where we're letting Tapis know more about that system so it knows how to run batch jobs using that VM. So with just a few changes to that definition, including the ID, we'll need a new ID. So we have HPC here instead of VM. We'll be able to create another system. So we have all the usual attributes we've talked about before. But in addition, we let Tapis know that this system can run batch jobs. I mean, it can still run fork jobs, but we have this can exec true, meaning you can run jobs, and then can run batch means it has a scheduler on it. And so Tapis can use it to run batch jobs through that scheduler. And then so we tell it the batch scheduler slurm. There's something called a batch scheduler profile, which essentially encodes some things unique to a lot of times you have things unique to an HPC center. For example, the module load command is not the same everywhere. So that in that profile contains things like the module load command and the modules you want to always load. And then we also need to tell it what queues or partitions are on that host, what HPC queues. So I won't go into a lot of detail here, in the weeks of time, but this one only has one queue defined, and this is a Tapis queue that's defined. So Tapis will reference this queue by the name Tapis normal, but then it does map to the actual HPC queue defined or partition defined on that host or HPC cluster. And so you can actually use the same HPC queue and have multiple queues defined here with different properties if you wanted to manage it that way. Essentially using Tapis as a sort of another level of front-end queuing. So, and then in case there are multiple queues, we define which one we want it to go to by default. And so one thing I did want to mention is, maybe I'll mention that in applications. So some of these things, there are a few things here that can actually be overridden in the application. And by overridden, I mean during the flow of a job execution, there's often several places where you can specify things like what queue you want your job to run on. That can actually be specified in 3 places. You could specify in your job submit request directly. So each person who submitted a job might say, I want this run of this application to go to this queue. But you can also define a queue in your application, which we'll see in a moment. And that one, and so that can be sort of a default queue if people don't specify during the job execution. And then finally, you can define this default queue in the system itself, basically meaning if, when the job service will use that queue if it's not defined anywhere else. So if the person submitting the job didn't specify a queue, and the person who designed and created the application didn't specify a queue, finally, it will be retrieved from the system definition. Because when you're doing the batch job submissions, of course, ultimately, somewhere you have to figure out what queue it's going to run on. So we'll go ahead and create this system. If we run that cell, and now we'll have a second system. So it looks like that worked fine, and we can list all our systems, and now we should have 2. Look very similar, except for the name. And then we can fetch the details of that one. We should see that we get a lot more information. So, there's quite a bit to a system to support various use cases, including DTNs. But again, don't have a lot of time to go through a lot of details. Let's see. Yeah, I think we've covered most of the important things for systems. So, and as before, we need to register the credential. So that's something I did want to mention. So when you register a credential, it's for a particular system. It's actually by system. So earlier we registered a credential on the sort of standard VM system for our user training, in this case, training 60. So training 60 has a credential registered on that VM system, but not on this system. It's a new system. So we'll need to tell Tapis that here's the credential for this particular system and that user. And so that now we should be able to list files again on this new system. And they're the same files we saw before because it's actually the same host that it's going to. See, can't see the chat easily, but I hope if there are any questions, just speak up.
There's a question in the chat.
Okay, yeah. So the second system comes. Yes, exactly. So the difference is how Tapis will interact with it. In this case, by interact, the main difference is the batch scheduler, right? It'll submit jobs through batch. So if you attempted, for example, to submit a job to the first system, and you basically during the job submit request or possibly the application you used was really set up for a batch system, that submit would fail because Tapis would see that, oh, the system and or the app are not really configured as batch, so I can't really submit a batch job there. But systems can be set up to submit either way. As that second system, actually, you could run a fork type job, what we call a fork type job, non-batch job, on that first system, on that second system we defined. So we basically were just setting it up as capable for batch, but you could still just have the one system. That was one goal with Tapis 3, version 3, to reduce the number of systems and applications that need to be defined. And V2, it's a little harder to reuse the resources. So, right. So, yeah, as Joe mentioned, we're doing this just to illustrate how it works. And in real life, you probably would not support both fork and batch on a single system. I think that most centers wouldn't like you to run fork jobs on their login nodes, for example, very often. So now we have our two systems set up, and then we'll go on to applications. So now that you have the systems and can list files on it and manage files, use them for storage, you probably have a job or an application you want to run on there. So that's the application which we've been talking about. And so what's interesting about this? So here we have, again, we're going to create two, I believe, one for the VM host that's set up as a fork, the application intended to be run as fork. And again, just to illustrate things. And then one that we can run as batch. So it's the same application, actually. It's an image classifier, which no one's really talked about yet, but it's I believe it's based on the Google TensorFlow. It's a Python program, and we running it and giving it, essentially we'll run this app and give it an image file to try to figure out what that image is. So all the examples we use this. And so there's an application, as before, there's an ID, and it's the same restriction there. The ID will need to be unique, in a tenant. But as Joe mentioned, the applications we expect people to develop and sort of evolve over time. So there's also the version. So to uniquely identify a particular instance of an application, you reference the application ID and the version. And the versioning is fairly open. It's kind of up to you to figure out how to do the versioning, although we recommend a semantic type versioning, which is what's shown here, where we're starting off with an application called Gateways Image Classify, a dash for username, and then a versioning will start with this version 001. But what you can do then is you can develop your application and test it and make sure it works, and then people can use it and that specific version while you potentially work on the next version 002, for example, just like a software release. So if you're familiar with that. So an application, we have a way to identify it through the ID and the version, and then there's the description, and then you also need to tell it what runtime this application is designed for. In this case, as for most HPC systems, it's Singularity. And then there are a couple of ways to actually start up Singularity. Is another question? Okay, so there's a question about, I think Joe's answering it. So someone asked about the module load command, which you need to run before you run executables on most HPC systems. That's actually in that scheduler profile. That's where you can tell it what the module load command is, and then a list of modules that need to be loaded before your container runs. For example, here at TAC, we have a specific module load command and a name for the actual Singularity module that lets us launch Singularity images. So that's how we handle that. So in this application, so we tell it the runtime, and if there are any runtime options. In this case, Singularity has two different options, I think, on two different ways you can start it up: Singularity run and Singularity start. And then you also need to tell it, what container, where's the container it needs to run, that's going to run. And you can reference, like if you're running fork on a VM through Docker, you can reference Docker Hub to get the image. Or in this case, and actually for Singularity, you can reference Docker images as well, and it will convert the Docker images to these Singularity zip files on the fly. In this case, what we've done is we've converted it beforehand and put it in this generally accessible temp directory to save time, and save load on network traffic, because it can take quite a while to convert a Docker image to a Singularity image. Like sometimes I think as much as 10 minutes. So So we've actually done that ahead of time, just really to save time. So that's our image classify application, where the singularity image file is. And then we can also specify in this application the some attributes related to the job. And here we really just have the one we're specifying. There's a number of things you can specify in here. And all we're really doing here is telling Tapis when the job is done and you go to archive the results, go ahead and skip the Tapis generated launch files. But there are other things you can have in there, like include and exclude lists for, like, I want to exclude most output files, but I want to include certain ones. If you just want to transfer or archive certain outputs. And so there's one place I wanted to mention, that there's quite a bit you can define in an application, and a number of those attributes can actually be overridden in the job submit request, which I'll go over after the break. But for example, one thing you can put in here is which system will this run on by default. So there's an exec system ID attribute I could have put in here and pointed it at one of the two systems we've already created. But you also can specify that at job submit time. So, and there are a number of attributes that are waived, and then sometimes they're overridden and sometimes they're actually merged. So that's something to be aware of. And there was a fairly good write-up and read the docs into the jobs section about that. So we're going to go ahead and create this application. And so that's pretty quick. And as before, as with systems, there's a put app call you can do and a patch app to update just certain things. And now you should see that in our list of applications. That's our training 60. And finally, we can get the details. And here, talk very briefly about, well, just how many there are. So there are a lot of attributes that are involved, and a lot of them aren't even really shown here because we haven't defined a whole lot. But there are a lot of things you can and often do need to put into an application definition. So a fair bit of effort can go into defining your application and getting it to work right. So tried hard to make sure you can it's possible to create a single application and make it fairly generally useful to people. So not everyone has to create their own. But things like container arguments you can put in there, scheduler options for batch jobs, and then application arguments, for example. And the job type, here it's not set. The job type could be set to for per batch generally. Could be defined here in the app, or again on the job at job submit time. Okay, so that's it for applications. Yeah, so I think we're about right on time, and possibly people are ready for a break. So if you have any questions, let me know, or have any trouble.
I have a quick question about application definition. So for provenance tracking, does Tapis keep all the information that's defined for the application along with the activity that's happening? Or I'm just thinking, if you change a version or update something, how much of that provenance information will be kept?
So Joe can answer this too, and probably others. But well, first of all, it does record changes, so you can see a history, like when you modify your application. Okay. And so in theory, you could backtrack there, but also it records when you submit a job. It records what application was used. But I don't think at that instant it records the full application details.
You have to specify the version in your job, so you have the app version, so that
so
you can walk back.
Yeah, and Tapis knows, I mean, so you can have multiple versions of an application active at one time, and you can run different versions of the application at the, you can request different versions be run. So if you can do all that, and Tapis will remember which for a particular job, which version of the application it ran, and all of the attributes associated with that version of the application, all of the version specific attributes of the application. Does that answer it, Mona?
I think so. Yeah, thanks.
Okay, great. Thank you.
Just to follow up on that. So systems were essentially editable, but app versions should not be editable. You can create a new version, but you can't edit an old version. Or is that true?
Actually, no, that's not true. You can update an old version. But Tapis does track, what changes were made and when they were made. So
right. Yeah, and there's also an image, a container image at the end of the day, for the application, and you can change that too. Tapis can't know really if you change it.
Okay.
So we are.
That makes the reproducible part really a challenge.
It makes it a challenge. It does. Yeah. I mean, we so one of the things that one of the projects we have ongoing, Steve, is a sort of registry, a Tapis image registry that will ultimately allow us to. So right now we basically rely on public registries like Docker Hub, and Singularity Hub and stuff like that, where users at the end of the day can just do whatever they want. We don't really have a lot of control, but we're hoping to have like a registry solution. It'll start off as a Tapis registry, but our real hope ultimately would be that like the whole HPC and more broadly research computing community, gateway community, whatever, would be interested in kind of collaborating on this. And there would be an image registry for, research computing specifically, with the goal of reproducibility, where, essentially we have a bit more control. Not that we want to be gatekeepers, but that we can put some controls in place so that we can guarantee that, once images have been used as part of jobs in Tapis, for instance, and in Tapis's case, we can know that those codes are frozen and help with the reproducibility.
Yeah. And in lieu of that, gateways could do some of that on their own.
Absolutely. Yeah. Absolutely. If the gateway is that's right. If the gateway is, kind of in control of the images, then it can take care of that. Those are kind of frozen or whatever. Yeah.
Perfect. Thank you.
Yeah, you bet.
Okay. If there's no other questions, we're at our break here.
So welcome back, everybody. Hopefully everyone's back. So before moving on to jobs and executing your application, we wanted to cover a couple of other topics. Actually, before that, I wanted to mention that I think I misspoke earlier. I said we were going to be creating 2 applications, one for each system. So, and you may have noticed we only created one. So actually, that is a big point of the tutorial, or at least one of the main points we wanted to get across was in V2, Tapis V2, each application definition is tied to a specific system. So to run your application on 2 systems, you actually have to create 2 probably nearly identical application definitions in a lot of cases. So we did want to point out in this tutorial that we have one application can run on these 2 different types of systems. So that's what actually also leads to how do you say you do create an application that's generally useful to a lot of people, maybe everyone on the project. So you want to let them use it. You want to let them see the definition and use the resources you created. So how do you let other people see and use your stuff? So let's talk a little bit about that. So there are actually a couple of things. One thing is Tapis v3 has support for fine-grained permissions. So a lot of the resource types, not all of them, but systems and apps and do. So what this lets you do is, for example, create an application definition like when we have, you can actually let someone have read permission, specific user or list of users have read permission on that application, and they can then see the definition. And I think you can even let people modify it. But there's actually no easy way to let everyone in the whole tenant, the whole project, see and edit that definition. There's no public permission at this level. So, and the other thing is, even if you give someone read application on a application, for example, they can't necessarily use it to execute a job, because they're actually, you might call downstream resources that are needed, like the execution system it's going to run on. Let's say you have an application where you've actually specified the execution system in the application because you've set it up and you want it to really always run, or by default run on this certain system. Well, the person's unlikely to have access, might very well not have access to that particular system. So if they tried to run a job, it would fail because the Tapis would not say you're not authorized to use that system. So it's really individual permissions, and so it has limited usefulness in terms of sharing. So so in addition to permissions, we also have this general higher level concept or approach called sharing. So I'll talk a little bit about that. Should actually check my bullet points here. And one important note about these Tapis permissions is they are at the Tapis level. And so, for example, especially files, file also has the concept of permissions on file paths. But just because you give someone a permission on a file path through Tapis, it doesn't mean they can access it on the actual host itself. The host itself also has, most likely has native permissions that might very well prevent that. So that can be useful in certain cases, but it has some limitations. You can't give permission to everyone. Through this, you can't give permission to everyone in a tenant. And you can't just easily make it useful in terms of using a resource like an application. So let's go on to sharing a little bit. And there's so for both permissions and sharing, there's on the live docs, there are endpoints for this, and it's documented there in the Open API live docs that were referenced. So in addition to the fine-grained permissions, we have this sharing concept. And for example, maybe one of the more useful ones is you can share an application or a system with a specific set of users or with everyone in the tenant. So if you, for example, if you shared with everyone in the tenant by a list of users, that would be a problem when someone joined a tenant. You added a user to a tenant, it wouldn't be shared with them. So we do have this public sharing that allows you to essentially automatically share with anyone who's in that tenant. And what that does is it gives someone read access to the resource, like the system or application, but it also gives them sort of an implied access to these downstream resources. So if you set up your application right, and then you may have to share multiple things, but once you've done that, then people, for example, could run an application on a system without having those lower level permissions. So in the one case, if your application actually had in it a system or execution system ID, you would not need to do anything special for them to be able to run the job on that system. They would get sort of an implied read access for that system and any relevant file paths through Tapis. So again, that wouldn't automatically give them sort of native permissions on there. So that's something to keep in mind. So it can be a little tricky to design and set everything up to work in general for everyone, but there's a bit of dynamic capability in terms of in the system definition and the way things can be set up with an application to make it useful for multiple people to run a certain application. What's that I want to mention? One more thing about sharing before we move on to jobs is, so for an example where the exec system ID is not in the application, you won't actually get implicit access to the system. Like say someone submitted a job and said, I want to run this job. I want to run this application on, on this other person's system. And they specified in the job submit request. Well, they don't have this implied access to that other system because they told, Tapis the actual system, and it's not defined in the application. So it's not really a downstream thing. It actually happened. What I think of as upstream, it's in the job submit request. But, so the solution for that is to, you can create a system and make it public, share it publicly with everyone in the tenant, and then it would be available to everyone in the tenant, and you wouldn't need to do anything more. For example, here we're working on a general definition of Stampede 2 in the TAC tenant that anyone would be able to use, and it has all the queue information and that type of thing. So not everyone would have to create their own Stampede 2 system for their own use. They would be able to use this tenant, this general public one, but they would need to register credentials. So that is something that needs to be done on a user by user basis. So that wraps up the permissions and sharing. So I think we're actually ready to move on to jobs. So does anyone have any questions about anything so far, actually, or any problems with the notebook?
I do have a question about application permission. Did you say that the application is defined per system? So if you have the same application on 2 different systems, you need to have 2 separate definitions?
Oh, no, sorry, it can be, but what I was talking about was, probably should have made it clear, is in Tapis v2, the way it was designed, the application definition actually was tied to a specific system. And that's no longer the case. So that's one goal of V3 is to break that dependency. So you can specify the exec system inside the application, but it will be a default exec system. It can actually run on, in theory, it can run on any system, the application.
Okay, so if you define an application, you could give it a default system that it will run on, but the user may be able to override that and choose another system. Is that correct?
Yes, that's correct.
Okay, thanks.
Okay, and that kind of leads us into the jobs where we can actually see specifying a system to use to run a job. So for those following along in the materials, we're going to go into the intro to Tapis jobs area. I'm just going to cover a couple of the intro slides here for the Tapis jobs. So the job service, it basically aims to launch one of your containerized applications directly on a host system and submit that to whatever execution type you've chosen. So whether it's a fork system that's just running basically on the host, the host you're submitting to, or if it's a batch scheduled system like a cluster system that's going to farm that job out to a bunch of other nodes. So that's the kind of main purpose of the jobs service. And just kind of to recap so far, what we've done here with the tutorial is, you have access to Tapis. You've registered two different systems with Tapis, the VM fork system, and then the HPC VM system. And then you've created an app that we're going to be able to leverage for running on both of those 2 different systems. So we're going to walk through that. The job service needs both of those Tapis objects that we created, a system and an app for our job to execute. And it also is going to be leveraging the files API to be moving data around, as well as the security kernel service for accessing the credentials to be able to talk to all these different systems that it needs to. And as we stated before, the Tapis v3 job surface is specialized to run containerized applications on hosts that support them. Currently, Docker and Singularity are the two that are supported, the runtimes for that. So the way the jobs API basically kind of works is you as a user can submit a job definition to Tapis, basically submitting a workflow, and then Tapis will sort of pick it up and it will do some other things before it starts to queue the job. It'll basically request authorization. So it'll make sure that one, within your request, you know, your JSON web token, that token that you're passing, is valid and good. And then it's going to look at all of the resources that your job is going to need. So the system that it's going to run on for the job itself, if there's any files you're going to pull from other systems or you're going to archive to, it's going to make sure that those systems also have correct permissions or shares on them, as well as the app itself. So it's going to check everything to make sure it works for there. And at that point, if it passes all those, it will actually create the job within the jobs database, and then it will queue it up. And so then it will kind of hit this point where it goes into a pending state, and then Tapis will start processing any of the job inputs. So that means it's going to start staging the container system on the system that you're going to execute to, pulling any input files that you've specified in your job, and then staging those to the appropriate directories where they're supposed to be on your execution system. And then once it's done all that, it will submit to whichever scheduler, basically, whether it's going to be running a fork job, it'll just run it on the system, or if it's going to be a batch scheduler, it'll submit it to Slurm. And then from there, it will monitor this different states that it's going to go through Slurm. So it'll be queued, and then at some point, it'll pick it up that it's going to be running. And then at what point it finishes, if you set it to do some archival, like move data to an archival system, specified an archival system, it will do that. And then once it's completed all that, it will go into a finished state. So these are kind of the basic stages that a job will go through. So I think those stages basically map to a lot of the statuses that a job can end up in. So the pending is the very beginning. And then, as we said, processing through inputs and all of these sorts of things. There's some other pieces here that are kind of the end, like blocked, if there's something that has blocked your job from running, or if your job's been paused, canceled, or if your job has failed, you can get some statuses on that. So there's different ways to monitor, which position of execution that your job is basically in on that. So let's see. So basically, as we've had, system objects and app objects, you've seen that we've put together sort of these JSON definitions for those objects. The jobs is basically the same. We're setting a bunch of key value pairs here. So giving your job a name, giving it an application ID that it's going to use. So in our case, we're going to use the image classifier application that we're going to run, and then which version of that application, and then a set of parameters that your job is going to need. So whether it's environment variables, archive filters, command line arguments, which we'll see in our example, are some of the other things that we can pass there. The most simple definition here is basically this one, where you have a name, the application ID, and the app version. So if your job doesn't need anything else, this is basically those things that you can have in the definition. If your app has a bunch of defaults set, this is the simplest one. So let's go to our example here in the notebook. So if you go to the jobs section here, what we're going to do is we're going to run our image classifier on our VM system using fork, and then we'll run another job using HPC and batch. So let's see. If at any time anyone has questions, just pop up, because I don't have the chat window open right now. So let me know if you have questions. But so basically here is some of the JSON definition that we're going to define for our job. So our job type in this case for our VM is going to be fork. And then we're going to give it some parameters here. So the parameter set that I mentioned earlier, we're going to pass it some application arguments. So in this case, the image classifier needs this image file argument, as well as a URL to a image file to classify. So we'll pass both of those in this parameter set field. And then to submit the job, so we will use our Tapis client that we've been using for setting up our systems and our apps. We'll use the jobs API, and then we'll use the submit job command here. And then, so on top of some of this definition stuff in JSON that we set here with the TapiPy stuff here, we can pass in a name parameter for what we want our job name to be. We can give it a description. Then we can tell it which app ID we're going to use. And so in this case, it's the app ID that we defined earlier up above. So this should be that image classifier app ID. The execution system. So in this case, we're going to use the virtual machine, the VM one that we set. And then we're going to use the only app version that we currently have, 0.01. And then we'll pass in this block of JSON definition here for the rest of these field parameters that we're going to pass in for submitting the job. So if we execute this cell, it ran that, and then we stored the response in this job response VM variable. And so we can reference that below here to print that out. So we'll go ahead and print that out. And so this is the output that we see from the job. So this is the name of the app that we're running. So mine is Gateway 22 Image Classifier Training 54. Yours should look similar. And then we can see that a unique identifier was generated for our job. I think it's somewhere down low. Yeah, here it is. So every job that Tapis runs gets a universally unique ID, so that you can use that identifier to reference and get the status on the job and things like that. Speaking of status, as we look at the different attributes that we have here in our job, you can see that the status is pending, so that means that everything passed and it's pending here. And then I think, let's see, what are all the other things here? So execution system directory, where it's going to put all of its output. So a job will access a work directory, a jobs folder, and then it makes a new folder that corresponds to that universally unique identifier for the job, so that every job should get its own folder for all of the container, its staged inputs, its outputs, its logs should all go into this folder on the system that you're executing on. Here's the execution system ID that we ran. So this is all part of the capturing that provenance of what happens, when you ran the job. So these are basically all the settings. Here you can see our parameter set, so we know exactly what we passed into to run this job. So there's a whole lot of other fields here, but those are the important ones for now. So we can get a list of our current jobs. I think I've run a couple other jobs on this account just to do some testing. So you can see them, and they all start with their app ID, and then end with their UID here, and then a comma between them. So this is basically a list of all the jobs that I've executed with this training account. And then since we stored our submission for our job response in a variable, we can reference that UUID, and we can print it out so that we can get that field instead of having to look through all those other fields. We can say, I just want this UUID so that I can reference it to check the status of my job. So if we can do that with this get job status and pass in our job UUID into this for Tapis. And at this point, I've talked so much that the job has finished running and it's done. And so at this point, the image classifier has ran. And I see a bunch of chat stuff. Any questions for me? Doesn't look like it. Okay. So at this point, we can actually get the output of our job, which is what we, everybody is interested in at the end of the day, what came out of the job. So there's actually a get jobs output download function that we can call on the jobs API. We just pass it the job UUID, and then we give it an output path. So in Google Colab here, they'll end up being an output.txt file that'll be written out into our workspace here. So that's basically what this is. So we'll go ahead and run that, and then we're just going to print out the output that the API returns back. And so this is what we get here. So the classifier ran, and the content of it was, it said, hey, that is a Labrador Retriever, and this was its confidence score, like 97%, and then I had some other ones. So it's nice to do this. A nice feature that Tapis has is allowing you to get notifications at some different points in for job events here. So attaching notifications. So this is something we can do when we want to execute this job again and use notifications. So if you see, there's this subscriptions field here that we can specify how we want to be notified and what events we want to be notified on. I think this slide might be better for this. Yeah, this might be a little easier. So there's this subscriptions field that we can set in our job definition, and we can say, what's the event category filter? We can say any different change in the job status I want to get notified, and then the delivery target here we can use email or webhooks. So we'll use email in this example, and then we just pass it an email address and delivery address, so we can actually update this in our container here. And so I will put my email in mine to update this, and we'll go ahead and we can submit a new job. So basically, we're going to submit another job to our VM system, same inputs as last time, but we should get a notification this time. So we can execute that, and then you can look at the details here. And this time we can see that there's a subscriptions field that's been populated in this job, which I think is empty, should be empty in the last one, or not even present. So, okay. And now we can check the UUID, and we can get the status. And again, this runs pretty quick, so this one's finished here. But I should get an email when the job was queued, when it ran, and when it finished to let me know. So this is handy for if you have really long running jobs that you want to know that they started running, or they failed, or things like that. So it's very, very useful for that. To cancel a job, there is the ability to do that. So if you end up needing to cancel jobs for any reason, there is a cancel job function, and you just pass it the universally unique identifier for your job ID. So I'll just pause here real quick to take some questions if there's anything that anyone has.
Quick question on the subscription functions. You said that we can either do, what it can do is either email or webhooks. I'm not too familiar with what webhooks. What does that?
So a webhook would be like a URL to like another service, say like Slack or Discord, or basically any other service that has a post API. So basically it can run a post to some external third party system as a webhook. So instead of sending an email, it will do that post to that, so that if you wanted your notifications to come through Slack, you could set up the appropriate Slack URL or whatever.
Okay, thanks.
Okay, if there's nothing else, I'll just run through the next part here for the HPC type here. So in this example, you'll notice that we no longer saying, we're not going to say we're going to use fork. We're just going to pass in our parameters set here, and we're going to modify which system we're submitting to. So we're going to submit to HPC, but we're going to still use the same app ID that we've been using in the same version of the same app. So just one single app definition, and we're running this on a separate definition to be run on a batch system. So if we wanted to instead have a new HPC system that say maybe with Stampede 2, we could just swap in Stampede 2 as our system here and do this same submission, and this would run on Stampede 2 with the same app. So that's kind of the idea of that one app definition, and run it on whichever resource has container runtime environments, and so submit it to that. So we'll go ahead and submit this. And this time we'll just run these a little bit quicker. Oops, broke that. That's my app. Get the status. This time it's running. It's still running. And now it's finished. So I just ran that cell a few times to show you that it actually is updating the status in between there. But anyway, in this case, we can see if I go back here up to where we pulled the job details. The execution system that we use this time, instead of being the VM, is the HPC training 54 one that I defined as my batch system here. And then we also have the parameter set. And this time we didn't set a subscription, so the field is empty in this case. So I won't get any notifications on this one. And then downloading the output, we do this exact same way. We just say our Tapis client object, jobs API, get jobs output download, pass it in the UUID for our HPC job this time, and then set the output file. So this is actually going to overwrite the last output that we downloaded at this same location to our Google Colab workspace. I think actually if I click this folder, files, let's see, output. I'm not familiar with Colab to where this is supposed to end up, but if we ran this in, say, our local Jupyter environment, it should write this out to an output.txt in the same location as our image classifier notebook. So again, same image, so we get the same results as what we would expect. We see it's a Labrador retriever, and then next result was a golden retriever. This is a little script here just to take the output and organize it so that it's a little easier to read as the first five, the top five classifications that the image classifier came up with. So the Labrador retriever was the top one, and then the next one was golden retriever, and then I don't even know what kind of dog that is. Bull Mastiff, Saint Bernard. So okay. So let's see, anything else with jobs that I wanted to mention? One thing I will note is that we've only touched the surface of all of the things that can be part of job submission. So the read the docs is a very detailed section on all of the different knobs that you can tweak on submitting your job and the requests. And as Joe, I think, stated earlier, there is like setting modules and things like that. That is a part of the stuff that's contained in here. So how you would for your HPC, if there are specific modules that you needed to load to be able to run certain things, that would be contained within this additional documentation. But today we're just covering the super basics of being able to do this. So any other questions about the jobs right now before we go into some sharing? And then I want to make sure that there's enough time that we can cover some of the Tapis UI stuff, because I think that's a really cool project, and in the hands-on, you'll actually be able to stand up a Tapis UI instance, hopefully. So if there's no questions, we'll go on to sharing. I think Steve talked about sharing, but this is actually the commands for doing some of the sharing here. So if we wanted to share, say, our VM system, with another training account. If I want to just share this with, say, training account 52, I would just set the username equal to training 52 and give them read permission. And so then I can use the Tapis client systems API and grant user permissions. And so if I execute this, this user should have read access to this system. And then I can grant them specific read access on a specific folder. So my work directory, say I want to share some job results with them. I'll do this grant permissions for the files API on a specific folder to grant them read access to the specific directory and its subdirectories. And then I believe when we are in person, you're able to share, say, share your training account with your neighbor, and then collaborate and see what this is to list the systems and set the training credentials stuff, I think. But we don't have to do that for this. So we'll cover the sharing application piece here. So this is a big one for people who want for the gateways piece here, where you're going to define an app definition one time and you want to share it with your portal or your gateway community so that everybody can use this, one app definition. So this works really great. For us, we have a microbiome gateway, and we have some really complicated pipelines that we put together to make it really easy for users to click a button and be able to run these pipelines. And so we just create an app definition and we share that with everybody. So that's basically what we can do here. Is I don't think we need this. Wait, we do. That. So we'll go ahead and we'll create another app definition here that's called shared test. I think I've done this before, so I'll make my gateways 22 image classify shared test. So we'll make a new app, image classifier app here that I think has all of the same attributes that we basically set before. This time we'll share out our system ID VM, so we'll make that part of this definition so that when we do this share, Steve talked about those implicit permissions that we'll get through. So if we set this default system, when we share this application, then the other user accounts or the public accounts that we would share this with would be able to execute this application as well, because they would get those implied permissions. So let's go ahead and create that. So I made this new application here, and then these are all the attributes that we set. You can see that we set a default execution system ID for that virtual machine here. And now we can actually share this app. So via the apps API, so Tapis client apps share app, and you can pass in the app ID. So this is the one we just made. And then I can say, I'm going to share this with account 52, training account 52. So that shared it. And then I can get sharing info on a particular application to say, who has this been shared with? So if I use the get share function from the apps API here and pass it the app ID, I can say, what is it? Is it public shared? It's not, it's false, but these are the users that it's been shared with. So if you want to unshare the application, I could just input the same user here that I want to remove shared access for, and use the unshare app method there. And then again, if we get the share info, they no longer have shared access to this. So they shouldn't be able to run the application on the default system that there is implicit permissions shared with here. So if we want to do this public, there is a share app public endpoint that we can use. And so if we pass in our app ID, we can run that, and that should now be shared publicly. So if we look at the info on who this is shared with, we see that shared public is now true. So this should be available for everybody in the training tenant now to be able to execute. And again, the same way to unshare the app again would be to unshare app public and pass it the application ID, and then that would mark this as false. And then this would be how users would be essentially run this shared app ID. They would just, same way we run it before, pass in this case, since this is the virtual machine instance with the fork and not the batch scheduler, they would say job type and then the rest of the parameter sets, and then pass in the submit job name description, the shared app ID that has been shared with them, and then the app version. So, so if folks wanted to do that, I think I shared this with everybody. So you could potentially run my Gateways 22 image classify shared test training 54 project or application that was just shared with you in this fashion. So, okay. So I'll pause here for questions on jobs, apps, systems, all the things we kind of covered so far before we look at the Tapis UI piece.
I do have a question. Let's say your job does some output. Let's say it goes through 100 steps and it says, I'm on step 3 of 100, 4 of 100. If it does that kind of output, is there a way to capture and get that information with a combination of subscribing to the running job and also the output of the job? Is that possible?
So Joe or someone, I don't know if you can access, I think the standard out files are being written to that work directory jobs/UUID. So it's possible to look at those. I don't know if we don't have a built-in function for that, do we? I know we have one for actors to look at the log as it's.
Oh, like a special endpoint to just get the standard out?
Yeah,
that's a good question. Yeah, no, I don't think we do have that one. And Steve may know. You would, to get the standard out, that would be a nice little convenience function to add. But I think you would just specify the path. I mean, it could be discovered through the files endpoint, but it's also there's a convention on the naming there. And so I think you could always specify the actual file that you wanted. So yeah, but I don't know, Steve, is there a convenience method to just get that?
After the job is running, but I think you still have to specify the path, but while it's running, you would need to go through the file service, I believe.
Yeah, that's a good thought. We could add that maybe as a convenience.
Another question along those lines. So can you differentiate between the standard out of the science code versus standard out of the entire container? They may not be the same.
No, Tapis doesn't specify the container, so the container is, you're saying like, see, you're saying if the container contains like different, like a script and also a science code, and then the script runs and the script launches the science code, something like that.
Something like that, yeah.
Yeah, to Tapis, it's all just the standard out of the process of the container process.
Yeah.
Okay. Yeah.
So that's something to keep in mind when creating the containers. There's probably some useful conventions to follow. Yeah. Okay.
Yes. If your container writes out to specific, like a specific output file it has itself, that'll be archived. Like that'll be moved in the archive piece back to whatever system you're going to archive it, or it stays in your job work directory that you can download those specific files as an output file. Okay. Anything else before I hand it over to Jared to talk about show Tapis UI, and then there'll be some hands-on here to see if you can launch it in do a fork on GitHub and launch it in Gitpods and have kind of a basic scientific science gateway up and running that has some of the stuff from your training account. Okay, Jared, I'm going to hand it over to you. So Jared is one of our research software engineers that has been working on some of the Tapis UI stuff with some of the other TAC folks. And so he did some initial stuff with this React application to integrate streams, but yeah, we tapped him to do this tutorial for us.
Okay. Yeah, so if everyone goes to the intro to Tapis UI portion of the walkthrough, first thing that we'll do is we can go to a version of the Tapis UI app that's already been deployed. You can use that to see any of the systems applications, any of the things that you made over the course of the tutorial. So if I log into Trang account that has some of that set up. So this is the Trang account that Sean was using to create everything earlier. So if you go in the dashboard, it has an overview of the systems, files, applications, and jobs that were set up for this account. If I go in the systems, you can view the systems. It will give all the system definition information, both either as JSON or as just a typical human readable format. And that will have any system definitions that are available for that tenant and user. You can view files that are available on each of the systems. So yeah, these are basically the file systems available. And you can also upload files on there. So if I want to, say, take a file, I could upload it from the UI onto the system. You can also download the files from here. So if I select files, I can download that. So basically, it's just a user interface for all the Tapis API functions. Same with apps. There's a job launcher, so you can configure applications and launch them directly from this user interface. You can define all of the various details, go through and launch a job directly from here. These are information on any jobs that were run on for that tenant. So all of these jobs have been previously run and are complete. Yeah, so basically just user interface for everything. I'm going to go over how to actually set up and deploy your own version if you want to make modifications or create a customized version. So if we go to the next section, we're going to be using Gitpod for that. So at the bottom of this, it says that you will need a GitHub account, a local installation of Node.js, and a Unix-like environment. For this, you only need a GitHub account. So we're going to use Gitpods to deploy it. So that handles all of the other requirements. You don't actually have to have Node or anything installed on your local machine. So if you go to gitpod.io, you should have, so I'm already logged in, although you should have a login prompt that you can log in with your GitHub account. And once you do that, we'll have to fork the Tapis UI repository. So you can find that, there's a link here, you can find that at that link. So if you go to that link up, in the top right, there's an option to fork the repository. If you click on that, switch to, oh, I already have a fork of it.
Put it in UHCI or?
Yeah. My bad. I made a testing fork and I forgot to delete it. So you can only have one fork per account. So I'll put in UHCI repository. Make sure that this is deselected because we will need the GitHub pages branch later on to actually set up GitHub pages. So you don't want to only copy over the main branch. And then you can create the fork to your account. It'll create the repository. Okay, so this is now a forked version of the original project. So if I go back to Gitpods now, go to new workspace. Once you're logged in with your GitHub account, I should be able to take the fork that I created and it should show up in Gitpod. If you select that, it will basically pull the repository and deploy it in. It'll run a cloud deployment that you can view through Gitpods. That will take a second to actually complete. So the next step is, once that finishes, we're going to have to create an SSH key to actually be able to use it with GitHub or deploy it with Git pages. So let that finish running. This is installing all the dependencies and creating the cloud deployment.
So a really cool thing about the whole Gitpod thing is that it pulls in your repository, and then if you're familiar with Visual Studio Code, this is basically a web browser based Visual Studio Code, because you can see all the familiar icons and all the stuff in the workspace. So you can make edits and modifications to the code actually in here. And so as Jared was talking about the SSH keys, you can link your GitHub account with Gitpod so that you can edit and do all your testing and stuff in this, virtual cloud workspace and commit changes and stuff back to your GitHub repository. So it's pretty cool. I'm excited about it for the whole idea of being able to kind of democratize some of the development and abstracting some of the complexity of having to install all the dependencies on your local environment, when Gitpod kind of automates a lot of that for users, so they could necessarily just do a lot of development in a Chromebook even interface, or even an iPad if you have the patience for that.
So this is almost done building. It takes a bit. There we go. Okay, so if I go to link provided, this is now the version of Tapis UI that it deployed. I won't be able to log in the Trang account on this because it is currently set up to the wrong tenant. But if I were to change this, so if I try to log into the Trang account, it won't actually work. But if I change the tenant here, it'll update the deployment, and if I refresh this, should be able to log into the Trang account. Yeah. Yeah, so you can create changes directly on here and then send, yeah, push all that back to GitHub, which we'll go over in a bit. First, we're going to create the SSH key. So you can copy this command to create the key pair. This will create a public-private key pair. If you hit the plus icon in the terminal in Gitpod, it will open a new bash instance. Can copy that in. For the passphrase, just hit enter. You don't have to put anything in for that. And that should have created public-private key pair. So now we have to actually get the public key so that we can put that into GitHub. So if you type this command, this will output the public key and copy that over. And if you go back to GitHub, go to your actual user account settings. So that's going to be up in the top right corner where your user account is, in settings. Then go to SSH GPG keys and set a new SSH key. So copy that into there. That SSH key, I'll ask you to confirm your password. Yep, and that should set that. Yep, so that's now set up with GitHub. So if we go to the next section, we'll actually deploy your Tapis UI version with Git pages. Or GitHub pages. So go back to the fork of the repository you made. And go to the settings there. We're going to set up GitHub pages. So go to settings for the repository and the pages option, deploy from a branch. And in here, you're going to look for the GH pages branch and save that. And that should be set up. So now we have to configure Gitpod to use SSH. So if you go back to the code component of the fork that you created and go here, click on SSH, and this should have the SSH link for that. And then you're going to want to set the remote origin for the repository to use SSH. So git remote set URL origin, and then the SSH link that you just copied. So that's back in Gitpod. Put that over. Okay, so now we want to actually commit any changes that you made to the repository in Gitpod back to the fork that you created. So you can just copy this block to do that. That'll push in changes. So the only change that we really made here was actually changing the tenant. When it prompts you for the fingerprint, just type in yes. And yeah, so you should be able to type that into Gitpod and we'll deploy it.
So this is a pre-created node script to build this React project and then do the deploy.
Okay, so if you go back to the fork you created, should have a GitHub Pages link on this right side. So if you hit View Deployment, now this should be the deployed version of your application. So oh, maybe I didn't push the changes.
Did you commit the changes in the Gitpod workspace?
I thought I did. Let me try again.
Oh, was it done building? There is a short delay between when you do your commit and the GitHub Actions that rebuilds everything. So it could still be rebuilding. There might have been a second deployment.
Oh, that might be why.
So you go back. So go back to the main page. You see there's an orange icon, orange circle right at the top where it says Jared McLean Tapis training. Look at that. That is still building, I think, isn't it? It's not green. Or is it?
Doesn't seem to be building.
So
it's also possible that let me try to type this in again.
If it didn't finish building, then that page wouldn't show up though, right?
I could have a previous deployment from because GitHub Pages was set up with the original repository. So if it didn't finish in building the new changes, it would still have the previous deployment, just not the new one yet.
Okay.
Yeah, I'm not sure what's happening there. Let me
look at the GitHub Pages branch real quick. Yeah, check out the index.
Yeah.
Oh, are you not on the GitHub Pages branch? You're on main. Did it merge main into?
Oh, yeah. It's not going to have.
Oh, the GitHub Pages is the built version, so that's totally different. Yeah.
Yeah. Not sure. I think it would be. Yeah, it's kind of hard to tell with this since it's built version, but
this is more an artifact of the Gitpod to here. But basically, the idea is that you can fork the Tapis UI project and make modifications to this React JavaScript application that uses the TypeScript SDK for Tapis, and essentially, within a few minutes, have a gateway set up that is hosted on GitHub Pages. That's a big step for developers to kind of just start from something that is able to run jobs and list or run applications, list jobs, manipulate data systems and things like that. So.
And then as the main Tapis UI repository gets updated, you can also pull any changes since you have a fork of it. So you can pull changes into the repository that you have either in Gitpod or on your local machine, and that redeploy it to update it with any changes. If I did this now, I would just say everything's up to date because I didn't just create it, although the main Tapis UI project will be continually developed and changes will be pushed onto that. Any questions?
So Joe, you have some announcements and things for wanting to wrap up this and.
Yeah, that was awesome, Jared. Thank you very much. The Tapis UI is super exciting project. So yeah, I mean, I think that pretty much concludes the tutorial, everybody. We had, a few minutes assigned for any questions and answers that we wanted to do. And the other thing that I was going to mention is that we will be some of us at least will be at Gateways. I know Sean and I will be at Gateways for sure in San Diego. A couple of other folks from the Tapis project will also be there. And I wanted to mention that we will be having a Tapis user meeting there. So on Tuesday, I think it's at 10 a.m. Local time, Pacific time, we'll have a Tapis user meeting. I'll put up a little advertisement for that. So there's an advertisement for that on our web page, on our Tapis project website. So this will actually be the second annual user meeting joint with Gateways. It's going to be 2 hours. We hope to cover a fair amount of material, including things like new features that we've just worked on this past project year, as well as upcoming features. So some things that we're going to be doing next year in project year 4. And then we're also going to highlight quite a few different and interesting projects that have started using Tapis. So this isn't just Tapis, it's also our collaborators. We will hopefully be able to get through a series of demos as well, and plenty of time for questions and answers as well. So so this will be on site at the Gateways conference. We're also getting some Zoom coordinates, so those will be available soon here on the website. So if you're interested in attending, but you're not going to be on site at Gateways, happy to have you join via Zoom as well. But if you are at Gateways, we'd love for you to be there in person. So that's again Tuesday, 10 a.m. to noon local Pacific time. And yeah, I think that's everything I was going to say. Anything else, team, that we need to talk about or mention? Anagha, you got anything?
I don't think so, but if people have interesting case studies they want to discuss with us for potential for Tapis, we can be here and we can discuss that.
Yeah, absolutely. Mona, do you have a question?
I do. Unfortunately, I have a conflict meeting for your Tapis user meeting, and I saw on that list Globus. I was wondering if you would be willing to give a little bit of info about that.
Sure, absolutely. Yeah, we've been working with the Globus team. So we actually got an NSF supplement to the primary Tapis award this past year to do a Tapis Globus integration. So yeah, we've been working with Kyle Shard and a lot of the several of the Globus team members to develop essentially what will be a capability in Tapis to enable you to register a Globus endpoint as a Tapis system. And then once you've registered that Globus endpoint as a Tapis system, you'll be able to use the files API to basically manage data on that Globus endpoint, just like you would with other kinds of Tapis systems. So it's a kind of a Tapis Globus integration for Globus endpoints. And so we did some back and forth with the NSF on this. They really like the idea, but then but like always, they wanted us to reduce the budget. So we went back and forth a little bit. The first version will pretty much kind of it'll sort of be a minimal, I say, like, we have a lot of plans, but it'll be sort of a minimal, like you can manage data through the Globus endpoint, but we have plans, hopefully to either through an additional supplement or maybe a separate proposal, continue to integrate deeper with the Globus team. So Globus has Globus Server, and it has Globus Personal Connect, and kind of basically making it so that some of the more complex use cases, like use cases where federated authentication has maybe been set up on the Globus side, or maybe on the Tapis side, because we both have our kind of, as you've seen, we both have a notion of kind of federating identities and multiple layers of authentication. So kind of unifying that to the best of our ability, that's probably not in scope. I mean, that's not in scope for this first release, but we're hoping to kind of address more of that also as future work. But I think the initial release, Steve's really heading up this effort with a couple of other folks from the Tapis side and the Globus side. We're hoping this, this Globus effort will be out sometime early next calendar year, 2023, because we've done a lot of the work already, and all the design is done, and it's just implementation and testing now. So yeah, that's in a nutshell what it is.
Okay, thanks. That sounds exciting.
Yeah, thanks. Cool. All right. Well, thanks again, everybody. I know you're all super busy taking this big chunk of time out of your day to hear from us. So we appreciate it very much. And yeah, hope to see you all, at least some of you, in San Diego. And yeah, we'll be online here if there are any other questions. But thanks again.